Welcome back. Back for more punishment, are we? I'm Bill Witte, and here we are in MA091 again. This week we got all kinds of new stuff for you, but I think you'll find that the stuff from last week is going to creep in. It's going to sneak in on us. So remember that last week and this week you're not allowed to forget anything. Okay? Let's dig in. If you forget anything, by the way, though, you can always go to our homepage at montgomerycollege.edu/algebra and review what we've done here today. Okay? Now let's go. Today we're going to cover the rectangular coordinate system. That's going to come into play when we have equations with two different variables, two different letters. And this equation, for instance, has an x and a y in there. Okay? Now we could fill numbers in, but we'd have to fill them in pairs. And it matters which goes where. So we're going to call them ordered pairs because it matters what order they're in. Okay? Now some of them are going to fit, and some of them aren't going to fit. Let's take a look. What do you mean fit? Well, I got to show you. Okay? The point 1, 5, in other words, this goes in alphabetical order. So 1 is filled in for x, and 5 is filled in for y. 1, 5, does it fit? Well, let's see. We put in a 1 for the x and a 5 for the y. Not for the 2y, but just for the y. So the 2's still there. Let's see. 1 plus 2 times 5, your order of operations. Creeped in there. Order of operations. 2 times 5 is 10, so we got 1 plus 10. Does it equal 11? Yes, it does. So I would say that the point 1, 5 fits into this equation. Okay? Let's look at another one. 5, 3. Let's see if that bad boy fits in. Now, once again, alphabetical order. The 5 goes in for the x, and the 3 goes in for the y. 5 plus 2 times 3. Let's do the 2 times 3 first and get a 6. So 5 plus 6 equals 11. Okay, so that one fits as well. And you might think at this point, oh, they all fit. That's no problem. Everything fits. Well, I think you're going to find most don't fit. Okay, let's take a look at 4, 2. 4 in for the x, 2 in for the y. Let's see, 4 plus 2 times the 2. That would be 4 plus 4. Well, that doesn't equal 11. So that one doesn't fit. Okay? So they don't all fit, as you can see. Let's take a look at, let's start introducing some more difficult ones, if you would. -1, 6. Okay? Talking about fit. People say, oh, negative, well, that will never fit. Negative could be a factor. Let's take a look. -1 goes in for x, 6 goes in for y, so we've got to do our multiplication first. -1 plus 12, and son of a gun, -1 plus 12, I don't know if you know, is 11. So this bad boy does fit. Okay? Okay, let's look at one more. 5, -1. That doesn't mean that they all fit. All the negatives fit. 5 in for x, -1 in for y. 2 times -1, -2. This isn't even close. 5 plus -2 doesn't happen. So it doesn't fit. Okay, so you get the idea of what I mean by fitting. Some fit, some don't, into an equation. I just want to make sure that you know this very well. I want to look at a couple more difficult ones. Let's look at another equation. How about this baby? Y equals -3 plus 2x. Well, now in this one, the y is listed first in the equation. But that doesn't matter for ordered pairs. When you have an ordered pair, the x always comes first. Okay? So let's look at some more and see about fitting and not fitting, if you would. Okay? Let's see. 4, 5. Now in this case, the 4 is still going to go in for the x because it's listed first. Okay? Even though the x in the equation is second. Okay? So let's put the 4 in for the x and the 5 in for the y. And let's see if this bad boy fits. 2 times 4 is 8. Does 5 equal -3 plus 8? Ding-a-ling. Yes, it does. So that one fits. Okay? Let's look at another one. Now, what I want to introduce is some different ones here. For instance, 0. 0 is a number. You can win the lottery on 0. Okay? So it should come into play here. Okay? Let's take a look. Now, in this case, 0 is going to go in for x because it's listed first. Okay? And let's see if it fits. 2 times 0 plus -3. Well, we're checking to see if that equals 2. Okay? Well, it doesn't. So that goes in the doesn't fit pile. Okay? Let's look at another one. just so we get good at this. 1 and negative 1. In this case, the positive 1 is going to go in for the x, once again, and the negative 1 is going to go in for the y. Let's take a look. Does negative 1 equal negative 3 plus 2? I think it does. So that goes in the Fitteruna pile. Okay? Now here's an interesting one. This one is like, put this one on the refrigerator for your mom to see. This one's tough. This one has a decimal and 0. Okay? Can decimals be in there? Absolutely. We're going to see they'll be all over the place. Okay? The 1.5, the 1.5 is going to go in for the x. Okay? And the 0, of course, being the second one, goes in for the y. Well, let's see. 2 times 1.5. What's 1.5 of 2? Well, it's 3. Okay? So let's see. Does 0 equal negative 3 plus 3? Hi, Mom. Yes, it does. So that one, as crazy as it looks, that's a Fitteruna. Okay? Okay, let's take a couple more. 2, 3. 2 in for x, 3 in for y. I don't know. Negative 3 plus 4, does that equal 3? I don't think this one's even close. That goes in the dirt ball pile. Doesn't fit. Okay? Take a look at just one more, if you would. 2, 1. This one looks easy enough. The 2 goes in for x, and the 1, you guys are mean, lean, substituting machines by this time, I would hope. Okay? Let's see. 2 goes in for the x, and the 1 goes in for the y. So we got 2 times 2. Do your multiplication first. Does 1 equal negative 3 plus the 2 times 2 plus the 4? I think it does. So it goes in the good pile. Okay, now why in the heck are we doing this? What are we going to do with all these ordered pairs? Well, pretty cool. We're going to actually eventually draw pictures, okay, called graphs. Put them on what's called a coordinate plane. Okay? But before, I've been giving you the points. Okay? Now it's up to you to find a point. Every number, whether it's x or y, has, at least in these graphs, you're going to find has a matching number. Now, what if you have to come up with it? For instance, in this one, we have an equation, 4x plus 2y equals 16. And they're going to give you half of a ordered pair. 2 in the first one. Okay, now that 2 is going in for the x. My job is to find what y is appropriate. Okay? Well, let's see. If I put in a 2 for the x, and now, of course, I have to solve this baby. The 4 times the 2 is 8. Now I got to get y alone. So I have to undress that y, if you would. I got to get rid of the 8, and I got to get rid of the 2. Are you starting to smell where what we did last week is coming into play here? We're following the order of operations backwards, are we not? We're doing our addition, or subtraction in this case, to get rid of the 8. And then we're going to do, how do we get rid of that 2 who is multiplying? Don't even think about subtracting, because he's multiplying. The opposite of multiplication is division. Okay, so in this case, y will be 4. So only in this case, when x is 2, y will be 4. Bam, and there's an ordered pair. You found it. We found it. Okay, now in the next one, we're all turned around. In the next one, we have a 2, and you say, why isn't it a shame? Well, in this case, the y is the 2. So things could change. Let's put a 2 in for the y this time. Okay, let's see. The 2 times the 2 is 4. Okay, now we have to solve and find out what x is. I'm going to have to minus a 4 to both sides. Okay, let's see. Now I got to get rid of the other 4. In this case, I don't subtract, I divide. Okay, and what do we get? In this case, x is 3. So I have the ordered pair 3, 2. Okay, it really matters where that 2 is, whether it's in the x position or the y position. Okay, let's try a couple more. When x is 5, well, let's see. Let's solve this baby. 4 times 5 is 20, and let's get that y by itself. Subtract a 20 by itself. Are you starting to see that they're a lot alike? They're all the same, many of them, and they are. You're either solving for x if they give you y, or solving for y if they give you x. Let's take a look. Solve for y by subtracting 20, and divide by 2. And in this case, y is negative 2. Put that baby in there. There you go. And 0. Don't be afraid. What's 0 going in for in this case? It's going in for y. Okay, that's all right. We can deal. Put it in for y. 0 is a number. 2 times 0 is nothing, basically. And in this case, I'm just going to take it away. You can subtract 0. It's pretty easy to do. Okay, and I'll divide by 4. And bam, x is 4 in this case. So there you go. We've found 4 points that fit. We really don't care about the ones that don't fit. Okay, we're going to be spending time finding things that fit. Now, why would we want to find these? Because the next thing we're going to try and do is draw a picture of these pairs, if you would. We put a picture of these pairs on what's called the rectangular coordinate system. Okay, it's rectangular because that's what it's shaped like. Okay, it's length and width. Now let's take a look at what this thing looks like. It's going to have 2 lines, or axes, if you would. One of them goes left to right. That's going to be the x-axis. Okay. To the right, it shouldn't surprise you, x gets larger, and to the left, x gets smaller. There's the 1, 2, 3, 4, all the way up to infinity. You see where 0 is. And we're going to go all the way in the negative direction here. Okay, now that's the x's. Now it's a rectangle, not a line. The y-axis goes up and down. And as we go up, once again, we start at the corner there at 0. The positive numbers go up, and the negative numbers for y go down. Okay, so there's your what's called the rectangular coordinate system plane. It's actually a plane. Okay, and we can put points on that plane. For instance, the point 4, 5. Now 4 is the x and 5 is the y. So we're going to do the 4 first. That means you start at what's called the origin. We're always going to start, and that's the 0, 0 point. That's easy to remember, okay? Always going to start at nothing. We're going to start there to plot this. We're going to go, for x, we're going to go over 4. And don't put anything yet, because we're not done. This is an ordered pair. A lot of people want to put something there. And then from that position, we're going to go in the y direction up 5. And now we're done, and we place a point. That's the point 4, 5. Notice that this pair takes 2 numbers to plot 1 point. Okay? Okay, let's try a whole bunch more, because we need to be able to do this very well. Okay? Let's try the point 3, 6. That means the x, and go start at the origin and do the x first, go over 3. Now how come we went over to the right? Because it's a positive 3. Okay? And now from there, we're going to do the 6 part, which is the y part, and go up. And now we're there. And that's the point 3, 6. Okay, how about another one? What you got left? Oh, 0. 0 allowed? Hey, 0's a number. Give me a break. Okay, we're going to do the same thing we did before. Okay, let's see. The 5 is 0. I'm sorry, the 5 is the x, and the 0 is the y, right? Okay, so we're going to start at the origin. You say, well, this is always a shame. You're right. Okay, I'm going to go over 5 and up how much? Up none. Boop. There it goes. You can go up none. Okay, 0's a number. Okay, let's look at another one. Oh, what about 0 there? That's 0 in the x position. That means go over none, start at the origin, go over none, and up 2. Okay, that's where that one ends up. Okay? Okay, wait a minute. It's got to be harder than that. That's pretty easy, huh? Well, let's see. What about negatives? Don't get nervous. Okay, well, now that negative 2 is in terms of the x, right? So for the x, we'll start at the origin, and let's see. We're going to go back 2, aren't we? Back 2 for the x, and then it's a positive 4, so we go up, and that's where we end up. So it's no more difficult. Just go in the right direction, okay? Let's look at this bad boy. Ooh, 2 negatives. Well, negative 5 for the x. Okay, we went in the left direction for the x. Notice we're going negative 5 spaces, okay, not counting dots. We're starting at the origin and going negative 5 units. And now for the y, how do you go negative for a y? Well, we go down, okay? We're going to go down 3, and that's where we'll end up for the point negative 5, 3. There it is. That's the position. Okay, so we can actually draw a picture of these ordered pairs, if you would. Okay, one more. A negative and a 0. Holy, go to war. Let's see. Back 4 for the x, and up how much? Up none for the y. So really, if you think about it, the points, based on whether there's negatives or zeros or positives or whatever, can really end up anywhere on this plane. Okay? Okay, well, I want to show you something. This is so cool. These were the points that we found earlier in the program that actually fit into this equation, 1, 5, 5, 3, and negative 1, 6. Let's plot them. 1, 5 goes here, I promise, over 1 and up 5. 5, 3 goes there, big deal. I'm saying I get more than one. No, wait a minute, ho. Negative 1, 6. Back 1 and up 6. Do you notice something about these? I think it's so cool, cool as a mule. They line up. Is that cool as a ding? When I first saw that, lines that fit into an equation, or points that fit into an equation line up, it was like a religious experience to me. I got to tell you, I'm not kidding. What are the chances that they would line up? I don't think that's pretty cool. Let's look at these ones, okay? 4, 5, this is a different equation, the second equation we did. Okay, there's 4, 5, over 4 and up 5. 1, negative 1. 1.5, 0. Now, wait, what are the chances? Hey, you can have 1.5, okay? Is that, oh, I smell line up. Let's see, and 2, 1. That's pretty cool. Son of a gun, they line up. Now, consider this. If I was to try and draw that line, that equation, y equals minus 3 plus 2x, we're going to have a name for it. Any equation that has a y to the 1th power and an x to the 1th power, we're going to call it a linear, shouldn't surprise you, equation, because all the points, incredibly, the ones that fit into that equation, if you took them all of them, of course there's an infinite number of them, they all line up. Okay, so we want to get to the point then that if I, or somebody, just gave you the equation, okay, now we've talked about finding points, so if I just gave you the equation, you could draw that picture, that line of that linear equation. Okay, and that's what we want to talk about here. Graphing linear equations, drawing them, if you would, representing them on this coordinate system plane. Okay? Now you know what's cool? Here's an equation, y equals minus 3 plus 2x, we've seen it, and these are the points that fit, okay? And if we graph those points, we've done it before, 4, 5, 1 minus 1. You know, you knew they lined up, but do we have to go to all that work? It doesn't matter, really, we only need 2 points. It doesn't matter which 2 points. We don't need 4 points or 42 points. And it really doesn't matter which 2 points, if you think about it. Because look, if I pick these 2 and not the other ones, what line am I going to get? If I pick these 2 and draw a line through it, same line. If I pick these 2, and really, any 2 points, you hear the term 2 points determine a line, you're going to find out where that line is, as long as you have your ruler, okay? So your job is to, if I give you an equation, is to find 2 points that fit into that line, graph them, and you'll know where the line is, the collection of all the points that fit in to that equation. Let's take a look. Let's do one. Y equals 2x minus 1. Well, we need a couple points that fit in. Okay, there's an infinite amount of points, but we really, as I said, really only need 2. So let's get some. I'm going to put in, does it matter what I put in? No. I can put in whatever I want, so I'm going to make life easy for myself. I'm going to put in 0 for x, and 2 times 0 minus 1. So it's kind of like a little recipe for y. 0 minus 1. So in this case, y is minus 1. So let's graph that. Okay, now I need one more. What would be the next easiest possible point that I could put in? Why make it hard on myself, right? Okay, I'll put in 1. 2 times 1 minus 1. So in this case, when x is 1, y is 1. Well, that's just a coincidence. Okay, let's graph that, Jimmy. Now I'm going to do something crazy here. I know where the line is already. But just in case I made a mistake, I'm going to do one more. I'm going to be a troublemaker. I'm going to put in -1. I don't have to, but I'm going to put in -1. Let's see. 2 times -1 is -2. -2 and -1 is -3. So we'll graph the point -1, -3, back 1 and down 3. And son of a gun, there they are. Hi, Mom. There they are. Okay, now why did I do 3? There's 2. If I did 3 points and they look like that, what do you know? You know you made a mistake. You only have to do 2, but I always recommend do 3, especially on a test. Do 3 just in case. And if they line up, you can smile, because I'm not guaranteeing that it's right, but the chances of it being wrong are very remote. And if they don't line up, you know you screwed up. Okay? So all throughout the rest of this show, we're always going to do 3. Even though you're saying, oh, you only need to do 2, we do 3 just in case. We want to bury it. Okay? Let's look at another example. Well, I'll tell you what, you're going to find in the future that this is going to be a lot easier to put in different x's, etc., if we solve for y first. We get y in general, okay? And you're going to hear me say that, I think, a couple of times, okay? So how do we solve? Well, what's keeping y from being by itself? A 4x is keeping it, and it's adding to the y, so I'll subtract 4x. So 2y will equal 8 minus 4x. Now, who's bothering the y now? The 2, he's multiplying, so I'll divide by 2. Now I have to divide everybody or nobody. They're going to be mad. So I got to divide that 8 and that minus 4x. So in general, y will equal 8 divided by 2, 4, and minus 4x divided by 2, 2x. So there's my general equation, 4 minus 2x. And I'm going to put in various numbers in for that. Let's put in our easy numbers, 0. Let's see, 4 minus 2 times 0, or 4 minus 0, 4. 0, 4 is a point. Okay, let's put in another nice easy one. 1. 4 minus 2 times 1, 4 minus 2, is 2. So when x is 1, y is 2. And I like that we solved for y, because now I kind of have like a little recipe or a formula, basically, for y. It makes it easier. I don't have to solve it every time. I just have to compute it. Okay? Graph that. But now I already know where it is, but I'm going to do 3 just in case. Now, we're not going to put, let's make it easy on ourselves. We're not going to put in crazy numbers like that. Since it doesn't matter, put in whatever you want. What's a nice easy number to put in? There you go. Okay? 4 minus 2 times 2, 4 minus 4. Oh, this is easy. My mother could do this. Okay? Y equals 0. Bam. Graph that. And you know you're on fire. Why? Because they line up. Okay? Chances are they're on fire. Okay? Ding-a-ling. Okay? Let's look at another one. You think you know it all? You don't know nothing. Hold on. Okay? What do we, wait a minute. What do we have to do first? Don't forget, whenever you're solving or whenever you're graphing lines, you're going to remember, solve for y. Let's do it. What's keeping y from being by itself? The 3 and the minus 2x. Let's see, let's add a 2x to both sides. And who's the other troublemaker? We have to divide by 3. Uh-oh. Now, y equals 3 divided by 3 is 1, and 2 divided by 3 is 2 divided by 3. Okay, 2/3 x. Okay, don't worry, don't worry. Okay, let's see, what are we going to put in here? Let's make life easy. Let's put in your old buddy 0, 1, and 2. Well, let's see. Put in a 0, 1 and 2, it's going to get ugly. My suggestion is, since it doesn't matter, in this case, and we have a fraction, put in multiples of the denominator, which in this case is 3. Why do I do that? Since it doesn't matter, the numbers will be much easier if I put in multiples of that denominator, and it'll cancel out the denominator, since I am allergic to fractions. Okay? So that's what I'm going to have you do. Make it easier on yourself. So let's put in, let's see, what are multiples of 3? I'm going to put in 0, 3, and negative 3. Or I could put in 0, 3, and 6, but we'll try 0, 3, and negative 3 since it fits on this graph. Okay? If I put in 0, that's easy. Y is 1. There's 1 point. Okay? If I put in 3, now here's where we reap the benefits of putting multiples of 3. 2 times 3, you see what happened there? They canceled. Now that wouldn't have happened if I had put in a 2. It would still work, but it would have been a messy fraction. So that'll cancel. And 1 plus 2 is 3, so put in that point. Now let me put in a negative 3. And that'll kind of cancel. The negative will still be there. So I'll have 1 plus negative 2, which is a negative 1. Oh, I don't know. Does that baby fit there? Negative 3, negative 1. Oh, there it is. You know you're right. Why? Because they line up. 3 points. Okay? Okay, it gets a little bit more difficult. Let's take a look at some weird ones. 3y equals 6. What am I supposed to do first? Oh, that's right. Whenever you get baffled, remember your buddy. Solve, because you will get baffled. It happens to everybody. Okay, let's do it. The 3 is multiplying, so I'll divide. Okay, so there's my equation. Y is 2. Well, what am I going to put in for x? It doesn't matter. It doesn't matter. So I'll put in my easiest ones. The easiest things I can think of, since there's no fraction, are 0, 1, and 2. Why make it tough on myself? Okay? Now, if I put in a 0 for x, there is no x. So, well, it's simple. It's simpler. It's so easy it's hard. If I put in a 0 for x and there is no x, it says y is 2. If y is 2, y is 2. And guess what? You can graph it, 0, 2. And then the next one, it says y is 2. Well, do what it says. Y is 2. Sometimes it's just easy. And the next one, y is 2. Put in a 2. So sometimes when it's just what's called a constant, y is 2, you just simply put in, the number and graph the points. And I know I'm hunky-dunky here. Why? Because they line up. So sometimes you have a linear equation that looks like that. Okay? Let's do one more that's kind of weird. 2x. Now, how do we start these again? But you know what? This one doesn't have a y. And I would say, solve for y, and I don't see it. So what's the only other alternative here? Well, there isn't any y. I'm going to have to solve for x instead. So, I always try to solve for y, but if I can't, I solve for x. Divide by 2. X is negative 1. Well, in this case, what can I put in for x? Well, you don't got much choice. X is negative 1. Now, that's your choice, okay? Negative 1, or negative 1. So it's kind of a weird one, but it's one of those ones that's relatively easy. As long as you know what to do. In this case, x is negative 1. What were you going to put in for y? Well, there you can put anything you want. I'll put in my easiest one, 0. So I graph the point negative 1, 0. Put in a 0 for y. This is looking good. And put in a 2. Let's see. They line up as well. I know I'm king. Okay. We can do this with a calculator, by the way. Okay? Let's try it. By the way, before we do it with a calculator, I'm going to have to give you a tour of a graphing calculator, some of the buttons that you're going to need for this. Okay? One of them is the y equals button. Now note, the y equals button. It's not the 7y equals button or the 2y plus 9 equals button. That's the y equals button. That is why I've been telling you, this is another one of the times where it's going to be so much easier if you just solve for y. You're not going to be able to use that calculator as easily if you haven't solved for y. Now, some of the things we're going to ask, some other buttons on this thing, are the variable button or the x button. We can't say it's the x button. If you look at your calculator, it's listed as x, t, delta, all sorts of crazy things. It's because any variable can be really any letter you want. This one's, I'm going to call it the X button because we're using it as X. Okay, another button, the graph button. We'll be using that in a second. Okay, so note where that is on your calculator. The clear button is to get rid of stuff. Note where that is. Okay, now this button is the negative button as opposed to the subtraction button. They're different. So it's very important that you know the difference, negative from subtraction. Okay? And of course the on button. Okay, I had a little trouble with that the first time I picked it up. You will have to turn the thing on before it works. Okay? Now basically, to graph these things, which you're not required to do in this class, but you can use it as a check mark, we're going to turn it, we'll give you an example. We're going to turn it on. I'm going to hit y equals. I'm going to clear out what's there. I'm going to type in the equation that it's equal to, and I'm going to hit graph. And once I see the graph, it's going to, I can get rid of the graph by clear. Let's try it using the calculator. The first step is to turn this baby on. Don't want to skip any steps. Okay? And the on button, you may remember, is on the bottom left. So let me do that. Okay? Now, I'm going to have to hit the y equals button, which is on the top left. And in this case, I'm going to clear out what was there before with the clear button. And I'm going to type in 4 minus 2x. Now, the minus is different from the negative, so I'll make sure I hit the minus 2 and then the x button. Okay? Once I've got the equation in its entirety, I hit the graph button, which is the top right. And cool as a mule, it graphs that line on the coordinate plane. Now, if I want to get out of this graph and back to the normal part of the calculator, I hit the clear button. Clear clears out anything. Now, I can't resist showing you what happened the first time I ever did this. I think this is an amazing animal, this calculator. I had it on, I hit y equals, I typed it in, and when I first hit graph, I was just taken aback. It knocked me right over. I couldn't believe it. Anyway, let me clear out there, and let's look at another example, okay? Okay, let's review the buttons that we used last time first. The y equals button, the x button, the graph button, the clear button, the negative. We didn't use that last time. We used the subtraction, okay? And we used the on button. Let's do another example here. Oh, that was the alt button. I'm going to show you the alt button in just a second. Okay, let's try 5y plus 2x equals 15. Well, wait a minute. We have to do that first, so let's do it. I'm not going to go through the whole thing. You just have to trust me that that solve for y is minus 2x over 5 plus 3. Okay? So basically, to graph this thing, we use the same steps, a little bit more typing. We'll turn it on if we need to. Okay, have that in parentheses. We'll hit our y equals button. See how important it is to solve for y. Clear if we need to. And then minus 2x over 5. Now that's going to be a negative, not a subtraction. Okay? And then graph, and you're going to see the picture. Okay, and if we want to get out of that, we'll hit our clear. I'm going to try it. Let's go. We've got the on button. Okay? Y equals. I'll have to clear out. I'll hit the clear. Now I've got to hit my negative. Looks a little different, a little higher, a little smaller. 2. Now the x button. Divided by, that's the divided by 5, plus 3. And hit graph. Looks totally different, but it is cool. And there's your line. Okay? I'm going to clear that out, and we're in good shape. Okay. Let's take a look now at graphing linear inequalities, where they use lines, but they're not equal. For instance, this is a greater than. 2y plus 4x is greater than 8. What do you suppose you do first? I'm a little confused, remember? Well, we always solve for y first whenever we graph, basically, okay? So let's take a look. You know what you're going to do? We're going to subtract 4x from both sides. Same thing. We'll divide by 2. Bam. Okay, we're looking good. Now what do? Well, you know what we're going to do? We don't know how to do inequalities. We're going to pretend that it's an equals. Okay, we're just going to pretend it's an equals and find some points. Use our 3 easiest points. If I put in a 0 for x, well, let's see. What's y going to be? Y is going to be 4. So we're going to graph that point. What's another one? Let's put in a 1. And if x is 1, y is 2. So we already have 2 points. Let's graph that one. Okay, one more. I always like to do 3, you know. Okay.
Wait a minute.
No, we're not putting in minus 87. Let's put in the easiest one we know, 2. There we go. Make it easy on yourself. Okay. And in this case, when x is 2, y is going to end up being 0. Okay, let's graph that baby. Now we know we're okay. Okay, so we're going to, well, wait a minute. Now, this is an inequality. We've got to go back to reality here. That's where the line would be if it was an equality. But this is an inequality. Okay? Well, let's see what we do next is we go back to our original equation and say this is a greater than. It's not an equals, it's a greater than. Okay? Now, if it's greater than or equal to or less than or equal to, we want to include the points that are on the line. If it's less than or greater than or less than, we don't want to include them, the points that are on the line. Now, this one is not an or equal to situation, so we don't want to include those points on the line. But we're going to need the line. We're going to need to know where the line is to draw our picture. So you know what you do in this case? You do a dotted line. Let's take a look. I'll draw a dotted line, okay? Now, I really haven't put any points if you think about it, and I need to actually draw or shade, people will say, all the points where y is bigger than that, okay? Now, I got to warn you, many books will have you do the 0, 0 point or some test point for this. I don't recommend that myself, because it doesn't always work. What if the 0, 0 point is on the line, for instance? It's not going to work, okay? So I have an easier way. Consider this. We need to decide where to shade, okay? In this case, y is greater. Okay, well, where does y get greater? Does y get greater above or below? Well, y gets greater above. So quite simply, you're going to shade above. That's how you're going to decide. It's simple, much simpler than using a test point or something. Okay, and that's our answer, a shaded with a dotted line. Okay, let's look at another example. Uh-oh. We know what we have to do first. Okay, let's see. Add a 2x to both sides. Let's see, got to divide by 3. Okay, 3 divided by 3 is 1, and 2 divided by 3 is 2/3. Remember what points we're going to put in this case? We want to make life easy on ourselves. I don't think we're going to put in 0, 1, and 2 here because we have a fraction. Okay, let's look. I'm going to put in, no, not 0, 1, and 2. I'm going to put in multiples of 3, so that way that fraction will unfractionize, if you would. Okay, 0, 3, and in this case, negative 3. You could have put in a 6 as well. Okay, if I put in a 0, I get 1. If I put in a 3, the things cancel out nicely, and I get a 3. And if I put in a negative 3, we've done this one kind of before, they cancel, but the negative doesn't. So I get, what, negative 2 plus 1, I get a negative 1. Let's graph that baby. Now all we have left to decide, well, they line up, but this is an inequality. Let's go back to our original problem. This is less, it's not equal to, it's less than or equal to. For a less than or equal to, we're going to use a solid or a dotted? Well, it's or equal to, so we're going to want to include the line, so it's going to be a solid line. Okay? Now all we have left to decide, is it above or below? Well, in this case, y is less than. Where does y get less? Well, y gets less going down, so it shouldn't surprise you that you're going to shade, well, since y is less, you're going to shade below, and that's your answer. Okay, not so bad, is it? It very much smells like just graphing lines, except the only difference is we have to decide whether the line is solid or dotted. That's the additional step. And one other additional step, we have to decide where to shade. Okay? I don't want to say above or below because it might change. Okay, let's look at another example. What else you have here? Well, what do we have to? Always start off with that. We have to divide by, in this case, -3 is multiplying, so we'll divide. Okay?
Wait a minute.
Oh, do you remember from last week? If you divide an inequality by a negative sign, what do you have to do? By a negative number, we have to switch the sign. Okay, well, we'll have to do it. Just remember to do that. If you divide by a negative number, let's take a look. Divide by a negative number, that's going to be y. But note that I switched the sign from a less than to a greater than. -6 divided by -3 is +2. So that's not so bad. So once again, we're going to pretend that it's equals. Okay? Pretend y equals 2, and let's see if we can get some points here. I'm going to use the 3 easiest ones I know. 0, 1, and 2. And if x is 0, there isn't even an x here. What will y be? Well, it says y is 2. So it's 2. Let's see. And if x is 1, what is y going to be? It says, it's so easy it's hard, who's buried in Grant's tomb kind of a thing. If x is 1, it says y is 2. So y is 2. Well, this is looking good. And if x is 2, what is y? It says y is 2, Bubba. Okay, so we're starting to smell good here because they're lining up. We still haven't finished. Okay, we have to make some decisions here. Is this going to be solid or dotted? Well, the original schmiginal is greater than. So that means not greater than or equal to, it's greater than. So I want to not include the line, so I have to represent that with a dotted. Now, I have to decide, do I shade above or below? Well, where does y get greater? Y gets greater above, and that's my answer. Ding-a-ling. Okay, one more. This one gets a little bit crazy. Now, I don't want you to be startled when you see something like this. Let's look at this last example. 2x is greater than -2. What are we going to do in this case? Well, you say right away. But that's going to be a problem. Because there isn't a y, I'm going to have to solve for x in this case. We did that before. Okay, so since we don't have a y, we'll solve for x. Who's keeping x from being alone? The 2. We'll divide by 2. Okay, and in this case, the equation that we're going to graph is x is greater than -1. Now, we'll pretend again, go back to pretend land, pretend x equals -1. But that's still hard. How do I graph that bad boy? Well, what do we put in for x in this case? In this case, it tells me x is -1, Junior. So that's all we're putting in. Y, there are no restrictions. So we're going to put in whatever we want for y. We'll put in 3 of the easiest numbers I know. Let's take a look. For this case, I'll put in a 0 and graph it. For this one, I'll put in a 1 and graph it. I can put in a 75 if I want, but why make it hard? And for this one, let's see, I'll put in a 2 and graph it. I'm looking pretty good here. Why? Because the 3 line up. Okay, now what are we going to do here? Is it solid or dotted? Well, let's see. It's going to be dotted because it's not or equal to, it's a greater than. Okay, now here's where it gets a little bit tough. There isn't an above or below. Okay, I have to shade in this case either to the left or the right, but it's not that bad because think about it. X is greater. Where does x get greater? You only have one choice, left or right. Well, x gets greater to the right. Okay? So we're going to shade to the right. Okay? So ask yourself, where does x get greater? Where does y get smaller? Or whatever it is, and that'll help you solve that. Okay?
Remember.
Oh, it's time to review. Let's take a look for the rest of this show. Okay? What have we gone over today? The rectangular coordinate system. We can plot points or ordered pairs. We always start at the origin, which is that cross there, and we do the x first. We go over the number for x and up the number for y. Okay? Let's look at another one. In this case, the x is -2, so we'll go backwards 2 and up 4. Okay? We can even do both negatives. Back 5 for the x, and in this case, for the y, since it's negative, we go down 3. Okay? Remember those? And 0 can come into play here as well. In this case, we're going to go back 4 for the x and up or down, none for the y. It can happen. Okay? Remember about graphing linear equations, lines, if you would. Okay? We'll take one quick example. If you have to remember one thing about graphing, or for anything that has to do with lines for the next several weeks, and you get baffled, what should you do? What should you do? You got that right. Okay, who's keeping y from being by itself here? The -2x and the 3 are the troublemakers. We'll get rid of the -2x first by adding a 2x. We'll get rid of the 3 by dividing. Okay, now at this point, we're going to put in any 3 x's we want, but let's make it easier on ourselves. In this case, we'll put in not 0, 1, and 2. Let's put in multiples of 3. Okay, or multiples of whatever that denominator is going to cancel, in this case, cancel things out. Okay, let's see. If I put in a 0, y will be 1. I can plot that point. If I put in a 3 for x now, that'll cancel out. That's why I put in a 3. Okay. And the 1 plus the 2 will be 3, so I'll get out a 3. So I'll plot that point, 3, 3. Okay, let's see. If I put in a -3, that'll cancel, and I end up with a -2 plus 1, or 1 plus -2. Y will be -1 in this case. And let's plot that baby. And if they line up, I know I'm completely hunky-dinky. Because I have to draw all the other lines, all the other points, and most people say, well, you don't go dot, 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 dot. You're just going to draw a line. Okay, but think about it. That line is actually a collection of an infinite number of points. That's the idea. Okay? Okay, we're getting to the point where you have to take over. Okay? You have to go do your homework. I would remind you that if you get stuck for any of these things, or if you've forgotten anything, you can always go. That's the first thing to think about if you get stuck. Okay? Usually, once you solve for y, the calculator can help you out. A lot of other things will help you out, which I'll show you next week. One more thing can help you out, and that is the home page. Okay? I guess this would be under the second section, graphs of linear equations, and there's various things that you could go to, assuming you went to www.montgomerycollege.edu/algebra. Okay? We'll see you next week. Till then, do your homework. Bye-bye. Now, I wanted to leave you with some sort of visual to help you remember one of the more important things of the class. But I'm sorry, all I'm going to do is tell you, solve for y.